Okay, so here's the lab that we're going to do now. It's called Introduction to Spectrophotometric Analysis. Okay, and I will forward you the lab and what it's about, and you can read it on your own. What I'm going to do is do the setup and run the experiment and tell you what you need to record, and we'll be doing the graph and etc. We'll be using some new equipment as we go along as well. So you're going to be using a spectrophotometer, and a spectrophotometer, what it does is it measures, you can have it measure how much there is of a certain color. Okay, and how do you do that? Well, you measure the wavelength of that color. Okay, so all colors are basically from absorption and or what's the word? Or transmission of light, or which is electromagnetic wave. And so what we can do is we just measure color by measuring the electromagnetic wave of that color, and then we can actually measure how much, how dense that that color is at that particular wavelength. So we're going to do two experiments here, and so the first thing we have to do is we have to make up our solutions, and it's a little complicated. And I'm going to go through, first of all, show you the calculations on how to do this, and then I'll probably be turning off the video, and then next step was I'll be actually making the solutions, and then finally doing the two experiments with this. Okay, so the chemical that we're going to use is this guy right here. So the concentration is 0.0200 molar KMnO4, which is potassium permanganate, and that's our stock solution. And so we're going to be using that to make up other solutions. So we won't be using this as actually part of our experiment, but we will use this to make our experiments. And so what we're going to do is do some simple dilutions. But so I'm going to show you the calculations on how we're going to go about doing that. Okay. So when you read the experiment, all right. So let's see if we can get it a little closer here. Okay. So the first thing it tells us to do is make prepare a it says 0.002 molar potassium permanganate solution. I want to change it to scientific notation, so I'm using all scientific notation here. So I'm going to call this dilution number 1, which is 2.00 times 10 to the minus third molar KMnO4. How am I going to make that? So I'm going to take 25 mils of this guy here. Okay, and I'll show you how to do it. And that's our stock solution. And I'm going to add it to a 250 ml volumetric flask. Okay, and I do that carefully. Okay, I'll show you how I'm going to go do that carefully. And then I'm going to so then I'm going to set it aside, and I'm going to mix it up and set it aside, and I'm going to label it as 2.00 times 10 to the third molar potassium permanganate. Okay, then what I want to do is make another solution, which I'm going to call number 2. And I'm going to prepare it using, and it's going to be a 2.00 times 10 to the fourth. So you can see that it's going to be a 1/10 solution, just like the last one is. So you're going to basically take 25 mils of your stock, which in this case, your stock is what you just made up. I won't call it the stock, but it's a 2.0 times 10 to the third molar. And I'm going to add that to 250 mil, and then bring that to 250 milliliters with distilled or deionized water. And again, I'll show you how to do that. Mix it up and label it. I'll probably just label them number 1, number 2. Okay, then, and we're going to use number 2 for the first experiment. Okay, now for the second experiment, the lab asked us to make 3 solutions that are between 0.00005 molar and 0.0003 molar. Okay, I don't like all those zeros, and I don't know how to compare them because we need to compare those 2 numbers. So I'm going to write them in terms of their scientific notation. So the first one is 5.00, or just, I guess it should just be 10, okay, times 10 to the minus 4th. And then the other one is 30.0 times 10 to the minus 4th. Notice I didn't use scientific notation for that one because I want to have it relative to the 5.4 times 10 to the minus 4th. Okay. So I want to have 3 solutions between those 2 values. Okay, well, so if I look back, I will see that solution number 1 up here is 2.0 times 10 to the minus 3rd, which is the same thing as 20 times 10 to the negative 4th. So that falls between that region. So I don't have to make up, so I just need to make up 2 because I have one that's between these 2, which is number 1. So what I'm going to do, I'm going to make it simple on myself. So I'm not going to make a 5, I'm going to make a 10 because it just says between 5 and 30. So, I'm going to make a 10, and the way to do that is just take this guy here and just dilute it in half. Okay, so I want to make 100 mils. I forgot to put that in here. Of the 10 times 10 to the minus 4th. And I'm using number 1, this guy up here. So I'm simply going to take 50 mils of number 1. All right, and then I'm going to add it to a 100 mil volumetric flask, and then bring that to 100 mils with deionized water and mix it. Okay, finally, so right now I have a 10 and I have a 20. Okay, so now I'm going to make a 30. To make a 30, I am going to use my stock solution. So my stock solution is 2.00 times 10 to the minus 2nd, which is the same as 200 times 10 to the minus 4th. Okay, so I want to dilute this guy to this. Okay, and it's not as simple, just half and half. So what I'm using my dilution formula, which is CS VS equals CV VV, all right, or C1 V2 equals C2. C1 V1 equals C2 V2. All right, and you should have covered this in General Chem 1 on how to do this. So I want to know how much of my stock solution I need to add to a 100 mil volumetric flask to get and to get a final volume concentration of 30. So what I do is I want to solve for VS, and so CV is my CF is my final concentration, which is 30 times 10 to the minus 4th. The volume is 100 mils. Should be 100.0. Okay, all these should be 100.0. And then my stock solution is 200 times 10 to the minus 4th. When you do the math, you come up with 15.0 mils of my stock solution. Okay. And what I'm going to do is add 15 mils of my stock solution to a 100 mil volumetric flask, and then add water until it gets to 100 mils, and then and that'll be my mix. And I'll label and I'll have these labeled. Okay, so So that's the calculations. Okay, so I'm gonna turn this off and get set up, and then we'll actually I'll make up the solutions.